Let's now implement equality for the derived cooked food class. We'll start with the objects.equals override. I type in override and let Visual Studio give me the method stub, and I'll paste in an implementation. Now this is different from what I did in the base class, and the reason is that when I was implementing objects.equals for food, I had to do all the equality logic. But now I don't, because most of the logic is already in the base class method. Let's see what I've done. The first thing we check is what the base class equals method returns. If the base class says that the instances are not equal, then there's nothing more to do. Clearly the base method found some reason to think the instances are different, so they are different. But if the base class method thinks the objects are equal, then that means all the base class checks passed. And recall, those checks say that the instances are the same type, they are not null, and all their base class fields are equal. But we still need to check any fields defined in this derived class. And in this case, there is just one field, the cooking method. So you can summarize this logic as return true if the base method returns true, and any additional fields in the derived class are equal. Now notice here that I'm relying on the base method to do all the null and type checking for me, and I'm trusting it'll do that because I wrote it myself. If for any reason you don't trust the base class method, then you can repeat some of those checks here. Or maybe just for performance, you'd like to do things like, say, check for reference equality before you commit to the base method call. That's fine, but I've written the code the way I have here because it's the simplest way to achieve what we want. Now let's deal with getHashCode. Again, type in override, get a method stub, and stick my implementation in the stub. What I'm doing here is I get the hash code for the base class, so that will be the hash code made up from the base class fields, and I repeat the exclusive OR trick and exclusive OR the base class hash code with the hash code of the one field in the derived class. And finally, we need to overload the equality and inequality operators. I'll paste those in. Those are exactly the same as the base class implementations. I just call the static objects.equals method, because I know that that will call into the virtual equals method and give us the correct logic. In fact, because those overloads are identical to the base class implementations, you could get away with leaving them out, but personally I think it's a bit clearer to have them in the code. And that's it. We have implemented equality for both our types, and we are ready to test the code. Let's do that. And it has given us the results we would expect for value equality. Neither baked apple nor plain apple is the same as stewed apple, but stewed apple is the same as stewed apple, and apple is the same as apple, even though they are different instances. And the final test, that the first apple instance is equal to itself, also correctly returns true. Obviously in a real app you'd want more thorough testing, in particular testing the equals methods as well as the equality operator, but hopefully that should give you a sense that we have implemented equality correctly.